Now let us explore the concept of normalization. This notebook explains how to use min-max scalar in coding from scikit-learn. We have already seen min-max implies normalization. This scalar normalizes the data using just a minimum and maximum values of the feature to transform the features to the value between 0 and 1. So this is the range that it will convert to. Now the package that we will be using are these packages. The first one is a pandas in order to handle the data manipulation. Next is a stat models. We will use this to import the inbuilt data that can be used to learn min-max scalar. The third is a numpy package. The fourth that we will use is a scikit-learn, and along with the scikit-learn we can use category encoders, but we will have the separate lecture for these category encoders. But for now we can just see here this library from scikit-learn.preprocessing. We have imported min-max scalar, and this is the library that will perform normalization. You can also create your own custom function and implement the mathematical formula, but we have the more optimized library that is inbuilt within scikit-learn.preprocessing, and the function that we will use is a min-max scalar. Now we have read the data right here. So using this stat models package that we have imported here, we are getting to read the data, that is inbuilt data. And now you can see if I run this line of code, then what you can see is within the data we don't have any null values. See here, we don't have any null values. So this is the code that will check if we have any NA or non values in the columns. So we have 0 null values, and if there was, then we can just drop the NA if there was any null values, but for now we don't have any. Now if I run this code to check our data frame that we have just imported here, then you can see we have these many fields. In fact, we have 25 columns. So columns are 25, and I have just printed 5 rows because I have just called the head command. So head will print me the first 5 rows, and here I can check out all the attributes that I have just read into my data frame. So first is year, month, day, departure time, scheduled departure time. So this is the data that is related to flights and Newark flights. So this was the data that is related to flights, and maybe something that is related to airports, and source and destination from where the plane was flying, and so on. So this is the data for it. Now within this data you can see right here the arrival time. This is the arrival time and scheduled arrival time. So this was scheduled and this was the actual arrival time. Similarly, we have something that is right here, maybe flight. So I'm searching for the flight. So I think we can't see the flight right away here. It might be hidden. So what we can do is we can also make the maximum column to be displayed as 25. That means I want to show all the columns. You can also do that, but for now here let us see that department time, we have this arrival time and scheduled arrival time. So these are the numbers. See here, these are the numbers. So I can convert them into hour, minute and second maybe. So to check how much was the arrival time, what was the actual arrival time for the flight, and what was the scheduled arrival time. So that is what we have done here. So here what we have done is I took the arrival time, and using this apply function I take all the data of this arrival time. See here, this is the arrival time. I took all the data one by one of the arrival time and give it to the lambda function ajax, and this will just create the arrival hour. And similarly, I also got the arrival minute, and I did the same for scheduled arrival time also. So if I run this now, if I execute this code, it is still running. See here, now it is executed. Now if I again print my head, then you can see at the end, you can see now arrival hour, arrival minute. So this is the hour. So in actual, the arrival hour was 8 hour 30 minute and scheduled was 8 hours 19 minute. So this was scheduled and this was actual. So it did calculate for all of these. So I can just convert this value into some hours and minute to perform the better, that is numerical encoding. So next what I've done is I have just created a module where I can split training and testing data. So y is here the label or my target variable. So this is my target, and x is that is my independent variable. So x is a independent and y is a target variable. Then I split the data into training and a testing sets, and I execute it. Now you can see all the data has been created and has been splitted into training and testing set. So we are going to discuss about this categorical variables encoding in a moment, but for now this lecture will focus on this min-max scalar, because this is the thing that I want to show you, and this is the process called as a normalization. So we saw in the theory lecture what is a normalization, what is the importance of it. Now you can see before the normalization our data looks something like this. So this is our data. So you can see numerical data, and this data has some values. Let's say within the month itself we have this data, in the days we have this data, and these are all our numerical features we can see right here. Now after I perform the min max scalar, so first of all I created the object of min max scalar, and using that object of min max scalar I called fit transform into the data that I want to convert into the standard scalar. So this is the standard scale, and if I use the normalization, the standard scale will be from 0 to 1. So that means after I execute this line of a code, all my data will be converted into the range 0 to 1. So here you can see initially they are not in the between 0 to 1. You can see 11 right here, you can see 16, you can see 5, 9. So this data is not within the range 0 to 1. Now using normalization I can make all of this data converted between the value 0 to 1. So for that I used min max scalar using only this function, fit transform function. Now I can just call this min max scalar, run it. Now it has been executed. Now let us check what has been scaled now. So if I execute this now, you can see it has returned us a numpy array which contains this data. Can you see here this data? So this data is the data of the previous data, now the same data that we have seen right here, but now it has been transformed into the range 0 to 1. Now after you perform the normalization, you will get the numpy array, but I don't want this numpy array. I want the original format, something like this in the pandas data frame. So I call the pandas data frame and I passed just the scaled value that we have got here, and I got the name for their column. Now if I execute them, then you can clearly see I can also get the head of it to show you. If I run it, then you can see all of these values now has been converted into the values of range 0 to 1. See here the month, here the first value it is 0.9. See here in the third it is 0.72. So you can clearly see now it has been within the range 0 to 1. So in the upper, in the original data, it has some random value. We don't have any standard scale here. You can see 293 right here. 108 was our observation. Now all the values has been converted into some standard range now. It is no longer our bigger values. So now using this data we can make our machine learning model. And if we use this data instead of the above data, then our model will have better accuracy. We will be testing this in our project, but for now you can see how to use min-max scaler. It is only this line of a code. Create an object of min-max scaler and call fit transform into the data that you want to normalize. So this is your input. So I have just given you an input here, so it can be anything. In our case it is x. So that means you can just create a normalization module where we can use this min-max scaler and call the fit transform, and after that all will be converted into some standard scale. And this scale that you have got here, the output that you have got is our numpy array. But we don't want to store them in this way. We want to store them into the pandas data frame like in the original format that we have here. So for that we execute this code where we created the data frame and we passed the scale value that we have just got here. This scale value is passed, and after you see here it has been converted again to our original data frame, and all the values has been scaled now. So this is one of the important topic, and this is very important, and this concept is called normalization.